This episode of the HVAC School podcast is made possible by generous support from Rector Seal, Carrier, and Testo. Testo is celebrating 60 years of high-quality instrumentation with their best-in-class fall combustion analyzer promotion. There's never been a better time to get a high-quality Testo combustion analyzer than right now. This offer is for a free 770-3 meter, the meter we've talked about a lot on this podcast, with Bluetooth and direct power reading and inrush amps and many more great features. You can get that meter for free if you purchase the Testo 320 or 330 series of combustion analyzers, or you can get a 745 non-contact voltage sensor if you purchase the Testo 310. This is a limited time offer, and you can find out more by going to hvacrschool.com/fall promo, which will take you to the Testo site where you can get the form to fill out. You do need to hold on to your receipt from whoever you purchased the combustion analyzer from, but of course we suggest if you don't have a local supply house that stocks these, you can easily go to TruTechTools.com, TruTechTools.com, and use the offer code GetSchooled, and you'll get an additional 8% off. Then just save your receipt that you get from TruTech Tools, go to hvacrschool.com/fall promo and fill out the form, and you will get either a free 770-3 meter or a 745 non-contact voltage sensor from Testo. Testo, 60 years of excellence. Perfect for testing, perfect for service.
And now, the man whose body odor has been deemed an ozone-depleting substance, according to the Montreal Protocol, Brian Orr.
Hey, yes, this is Brian, and thank you for listening to the HVAC School podcast. Thanks for being here. And the HVAC School podcast is actually lives on hvacrschool.com. So if you've listened to the podcast and you've never been on hvacrschool.com, then I don't know what you're waiting on. There's a lot of people who I have talked to who are like, yeah, I follow your Facebook page, or I see you in the Facebook group, or I listen to the podcast, or I read the tech tips. But the truth is that HVACR School is all of those things, and the website is kind of the center point of that. So that's hvacrschool.com. That's my little plug for the website. If you haven't been there recently, I actually had somebody in the Facebook page who I shared an article, and he clicked the article, and then he wrote on Facebook that he was going to read the article, but shame on me for having an ad asking for his email. And I was like, well, it isn't really an ad. It's just asking for your email in case you want to get the daily tech tips to your email. But if you don't want to, just hit the little X button. I don't know why that's so difficult. But anyway, so that is one of the first things you might see if you go to hvacrschool.com is a pop-up, and the pop-up just says, hey, you want to sign up for the daily tech tip email? And if you do want to, then we will send you a daily tech tip. It's not like I'm going to be sending you, marketing, buy something from me or anything like that. That's not how that works. It is a daily tech tip email. When I say daily, it's not like 7 days a week. It's probably more like 5. I think on average, I'm averaging about 5 articles a week. And it's not only written by me. I write a lot of them, but they're also written by a lot of other really cool people, like Justin Skinner and Jeremy Smith and many others. In fact, I even got Jim Bergman to contribute some stuff. So he's a little more tricky to get. But anyway, today on the podcast we have a 3-time guest on the podcast, and that is Jeff Neiman. And Jeff Neiman is a chiller tech, and a really down-to-earth chiller tech. He's not like one of these super techs who thinks he knows everything, but he's a guy who's worked on a lot of chillers, and he knows a lot about chillers. And one thing that I know very little about, everything with chillers I know very little about, but I know very, very little about low-pressure chillers, and I've always been fascinated by it ever since my instructor in AC school dumped some R11 in my hands, and I was able to watch the R11 boil off, which is patently illegal, but I didn't do it. It was my instructor. I'm not going to name any names. But ever since then, and he was explaining, low-pressure chillers to me, and I was fascinated by that, and the fact that the low side of a low-pressure chiller is actually below atmospheric pressure. So, of course, that creates some issues. And Jeff said, well, let's talk about leak detection on low-pressure chillers. So today's podcast is on leak detection with low-pressure chillers. And so here we go. Jeff Neiman and leak detection on, you guessed it, low-pressure chillers.
I'm in my van, and it's raining out, so I don't know how the sound's coming through on my end here.
How does it sound to you, Jeff? How does it sound to you?
It's very peaceful. It really is. It's nice just to sit in the rain,
I'm glad. Because at first you sounded a little stressed out.
Actually, I'm very happy that we're doing this today because it gives me about a solid hour to where I can't break anything. So that's good.
Ooh.
At least I got that going for me.
Yeah, you can't break anything like out of anger? You can't break anything
No,
because
just
normally when you touch things, you break
me
things.
Being a big dumb animal.
Okay. So you just touch objects and they break.
At this point, I just have to look at them. I don't even have to touch them anymore. With that being said, this being my third time doing the podcast, I'm looking forward to visiting my self-portrait in the hall of HVAC School podcast.
HVAC School, the pretend corridors of our pretend palace where we keep the honored guests. You will be forefront. It will be so. If you look to your right, you'll notice the photograph of Jim Bergman. If you look to your left, you'll see Nick Messick, and to the right over there, you'll see Jeff Neiman.
That's high praise. I'm very flattered.
You should be. All right. So today on the podcast, we have Jeff, third time's the charm Neiman, and we're going to be talking about leak detection on chillers, and not just any chillers, mind you, on special chillers. That's what they're called.
Very
special chillers. All right. So first off, I always have to ask you, because you do the type of work that I have always kind of wanted to do. Have you done anything interesting today or in the last few days?
Let's see. I don't know. It's all kind of interesting. Today, I had a system where they have glycol leaks all over the place, so that's fun. And they don't have the time to shut the chiller down and fix the leaks, so basically we're just adding glycol to it as it's leaking out.
Have you tried putting AC leak freeze in it?
I have not. I will recommend that to them and see what we can do. Yeah.
Instead of actually sticking the injector, feeding it, you actually just stick it right where it's leaking and just squirt it in there. Yeah.
All right.
Give that a shot.
I'm writing that down right now.
Okay, good. It won't hurt anything because it's an oil-based product. Okay.
Perfect.
Ignore all that last stuff that I said. I'm being sarcastic. Okay, so glycol leaks all over the place.
Yeah, glycol leaks. So the chill water pump on the suction side is running into a vacuum, and it's introducing air into the system through the shaft seal, which is introducing more leaks because now the air vent is trying to purge out air that's getting into the system and releasing glycol with that as well. So it's just going round and round, chasing our tail, trying to keep this thing in working order form until we can do the proper repairs on it.
Got it. So the proper repairs is shutting it down and actually repairing the leaks properly.
Yeah, and I'm actually gearing up to do repair on another chiller. Actually, this was a question that I posted to the HVAC School podcast page, Facebook page, with the vibration absorber on a compressor, to where the piping, 2 1/8 inch copper piping, the fitting actually cracked after the vibration absorber. So I'm going to redo the whole discharge line and install the absorber in the proper way and hopefully take care of that mess.
Well, what was improper about how it was installed?
It is installed perpendicular to the axis of the shaft of the compressor, and it is also installed as a riser, and there's no piping support after
got it. Okay.
Where it's installed, so it basically stretched it out over time, and it doesn't work no more. Long story short,
it's broke. It's broke. They did it wrong, and it's broke.
Something wrong, definitely.
Yeah. All right. So when we're talking about leak detection on chillers, which is what we're talking about today, there are chillers that are very typical in the way that we do leak detection, in that they are all positive pressure. So let's do that again. So for those of us who know nothing about chillers, let's talk about the two different typical types of chillers as far as pressures go. That was a really bad way of introducing that. Just go ahead and you know what I'm trying to say.
Yeah, no, for sure. Yeah, I mean, there's chillers that work with pressures just like every other piece of equipment out there, with a positive pressure, 134A, R22, 410A on the smaller chillers. And regarding those, you would leak check those just like any other package unit or residential type system. Then you have the low pressure chillers, where they operate, even standing idle, not in operation, they're sitting in a vacuum. They are below atmospheric pressure, and that's going to be refrigerants 123, R11. In rare cases, you'll still see some R11 out there. And leak checking those are a little
Mm-hmm.
more time consuming than your high pressure machines.
All right. So as far as the types of machines, generally the high pressure machines are going to be usually screw chillers, right? In most cases.
Yeah, screw chillers are actually, pretty much all screw chillers that I've run into are all high pressure.
Mm-hmm.
There's chillers that have Copeland scroll compressors on them.
Mm-hmm.
And those are all high pressure. In my experience, the only low pressure chiller that I've run to is a centrifugal type of chiller, and that's going to be either a Train or a York, an older York. York doesn't make any low pressure chillers anymore. Train's actually the only manufacturer that still makes those, in my experience.
Really?
Yes.
Those are the only centrifugal chillers that are being made currently are Train.
Well, that are low pressure.
Okay.
Yeah, low pressure.
So there are high pressure centrifugal chillers?
Yep. York, Carrier, McQuay, they're all 134A on the newer ones as far as centrifugal goes.
Mm-hmm.
So on the air-cooled side, again, they're going to be either 134A or 410A you'll see on the scroll chillers.
All right, so I want to address real quick. So I'm just going to take this little piece here because this is something that I know, which is rare that I know something. It seems like all my guests come on, they know all this stuff, and I don't know anything anymore. I'm like a big dummy. I need to do some more solo episodes so that way I get to gain some respect back from my audience. But the one thing I understand is that, so at atmospheric pressure, at sea level, pressure is 14.7 psia, and that's the pressure of the atmosphere all around us. And so I think we tend to think traditionally, when we think of a high pressure system, we think when the system is at 0 psig, which is 0 pounds per square inch gauge, that there's no more refrigerant in the system. We've achieved atmospheric, but that is just patently false. So when you are at 0 psig, which is when we were looking at our typical gauges, and they say 0, there's still 14.7 psia of whatever matter is inside that system. So you can have a system that has a lot of refrigerant still in it. For those of you who are universally EPA certified, so that means you have your class 3, the EPA guidelines go over this a lot, that you have to understand that in low pressure systems, you are functioning almost exclusively, or at least in the static state or in the low side state, you're functioning below atmospheric pressure. So you're dealing with massive amounts of refrigerant all below 0 psig, below atmospheric pressure. So the key thing I'm wanting to get to here is that just because you see 0 on a gauge that's at gauge scale, does not mean that there's no refrigerant present anymore, which is also true on a high pressure system. When you take a system and you get it down to, say you pump a system down to 0 psig and you open it up, that doesn't mean there's no refrigerant in that system. There is still refrigerant in that system. And that's why for certain systems, the EPA has guidelines that you have to pull it down into a vacuum to actually get out the rest of that refrigerant, with low pressure centrifugal chillers being a key place that it would be necessary. So I just wanted to explain that real quick. Just because you see 0 doesn't mean no refrigerant is present. And so now we're going to go into, if you were to run into a low pressure centrifugal chiller, what would you have to do? Well, first of all, let's cover this. What would happen if there was a leak? Let's say there was a leak on the low side of a centrifugal low pressure system. What would happen?
On a low pressure chiller where leaks are present, low pressure chillers have a separate purge unit that's installed on the chiller itself. And the purpose of the purge unit is to get rid of non-condensables that enter into the system. And typically, it's not a huge problem. The purge will take care of any real small leaks that happen to be there in the system. But once that leak or multiple leaks get large enough to where the purge cannot overcome the leak rate, then you have problems. And you're introducing excessive non-condensables into the system. Your head pressures go up. Your heat transfer on your condenser side from the refrigerant to the condenser water reduces, so your approach temperature will increase. And the operating envelope of that compressor will be exceeded. So the lift pressure, which is your difference between your suction and your discharge pressure, centrifugal compressors will have a design lift pressure, and that will vary from manufacturer to manufacturer, and there's a lot of variables that will play into there. But once you exceed that envelope of what it can do, it will start surging. It will have a stall, and it will surge. And a surge is just basically a reversal of refrigerant flow within the compressor itself, which is not good. And you know when they're surging because they will be screaming at you pretty loud.
They tell you. So when we think of leaks in a low pressure centrifugal chiller, it's not refrigerant leaking out, at least on the low side of the system. It's not refrigerant leaking out. It's or atmosphere or air entering. So it's the opposite of what we would typically think of. And so you end up with this additional air in the system, which then displaces the refrigerant. It's a non-condensable gas. And so it causes issues in the system similar to what a non-condensable gas would cause in a typical high-pressure system. But unlike a high-pressure system, it happens dynamically, meaning you're continuing to add this non-condensable gas, i.e. air, into the system the more that it runs.
Correct. Yeah.
Did I say anything incorrect there?
No, that's very accurate. It leaks on a low-pressure machine. Yeah, you're introducing air, but when the leak becomes excessive, there will also be refrigerant loss through the purge unit itself. A dirty little secret that comes with the purge units that doesn't get published in manuals and books and literature is that every time...
podcasts until now.
Or podcasts, but every time a purge unit vents non-condensables, there's always a trace amount of refrigerant that gets carried away with it, and they do a pretty good job of separating most of it under normal conditions. But when you have excessive leak and you have excessive purging going on, there's always some refrigerant that gets vented out with it. And one of the safeties that are with these low pressure machines, whether it's a Train or a York, there's max purge times or purge counts within a set amount of time. Whether on the York it's maximum purge counts per hour, and on a Train chiller it's max purge time per day. It's just a different way of that they have them set up. And so that's kind of a safety to where it almost seems counterintuitive, because it'll shut the purge down if it's venting or purging excessively, but it doesn't help the matter if you have a leak and your purge shuts down, then it just makes everything even worse. So
it's shutting it down because it doesn't want to either A, vent excessive refrigerant, or I'm guessing when it shuts down, it's alarming and telling you that this is occurring, and so it's more likely that it's then going to be fixed, right?
Yeah, it's basically telling you, hey, we're purging way too much. We have a leak going on somewhere, and it's a way for them to notify the operator or the technician that something's going on, and also a way to prevent excessive refrigerant purging out to the atmosphere.
Just a couple quick things to mention here. One thing that I want to mention is that I've seen an increase recently in different municipalities, different locations around the country, around the U.S., enforcing the installation of locking caps on new installations of systems. And so I'm going to just suggest to you that if you haven't started installing locking caps, that maybe you just start doing it now. A lot of people bring up that they don't like having to have the special keys for the locking caps, but the truth is that as other companies begin using these keys anyway, these caps with the special keys from RectorSeal, you're going to want to have these keys on your keychain anyway, and RectorSeal makes a great product. It's called the no-vent product of locking tamper-proof caps. And then you get the little keychain ring that goes right there on your keychain, and then if you ever run into a no-vent cap, you've got that right there on your keychain. So that's a good thing to have, a good thing to be prepared with. Even if you are not yet installing them, go ahead and pick up one of those keychain keys, so that way you and your technicians are prepared. Another thing that I want to mention from our sponsor Carrier, and again, those of you who don't know, I'm a Carrier dealer. We install Carrier products all the time. I'm really surprised and delighted, I guess I should say. Surprised and delighted that they are really committing to the ductless line. We've installed a lot of ductless over the years, but over the years we have not installed a lot of Carrier ductless. But lately we're installing more and more, and I am really surprised by the quality of the product, and it's improving. One thing that I really like that Carrier's doing is they're focusing on the serviceability of their air handlers, because that's always been a challenge, getting to the blower wheels, getting the units apart with a lot of the other brands. If you've worked on ductless, you know exactly what I'm talking about. And Carrier's making some really big strides in the ability to service and access those evaporator coils and those blower wheels. And one of their new products, you actually can take the entire blower compartment out with just 4 screws, which I think is pretty awesome. So Carrier, turn to the experts. Another product that I want to mention, they are not a sponsor at all, but it's a product that I really think is cool, that I think you should know about as part of this little segment here, and that is the pipe wiper product. That's made by A-Jacks Manufacturing. So you just type in A-JacksManufacturing.com, and you go to their website, and they have this product called the pipe wiper. And what it is it's just a system, a very simple system for you to push wipers, they call them, but they're really pigs. If you're familiar with how you can force pigs through a line in order to clean out a line, to flush your line set if you're going to keep an existing line set instead of flushing it with solvents. We've used solvents for years. We've used different products that are out there on the market, commercially available. And the problem with a lot of these solvents is, first of all, some manufacturers are starting to say, hey, we don't really want you using them because we're afraid that you're going to leave a residue in the lines. There's that concern. The other thing is most of them are pretty nasty. You get them in your eyes, get them on your hands. They're not the greatest thing. And then the other thing is just having that stuff dump on the ground isn't always the best either. I mean, let alone that you're not supposed to dump it on the ground, but if it damages a customer's, sidewalk or damages their plants or whatever, that solvent stuff just isn't the best. So with the pipe wiper, it doesn't use any solvents. All it does is just force that wiper through the lines. You just use nitrogen to do it. We find that it saves time, saves money, because the flush solvents are actually pretty expensive, and it works great. The concern that a lot of people have is that it's going to get stuck, but we show pretty well that that's not the case. We actually forced 2 through a line set that was a second story application, and it went through just fine. We did that by accident, by the way. But he also demonstrates on his website. You can watch some of his videos where he forces it through kinks and short radius 90s and all sorts of situations like that. So you can find that by going to A-Jacks Manufacturing, and he actually set up a discount for you as well. It's the same one that we use for TruTech Tools. It's Get Schooled, and you can use that to get a discount at checkout. So that's on the low side of the system, but on the high side of the system, you are above atmospheric pressure, correct?
Yes, most cases you are in a positive pressure on the condenser side. And when it's in operation, you can leak check that just like any other chiller with your electronic leak detector, whatever you happen to be using. But on the low side is still below atmospheric pressure. So while it's in operation, not a whole lot you can do to check for leaks on that until you are able to shut the chiller off.
All right, so let's talk to the process now. So you have a leak. Now what do you do next?
Well, you have a leak. We need to find that leak. So when you shut the chiller off, the chiller sitting idle more than likely is going to be below atmospheric. There's a couple different ways that you can increase that pressure to bring above atmospheric. And one of the more common ways is using a portable boiler or a hot water pack, some people will call it. And it's basically just a setup, a rig, like a hand cart that has a little circulating pump on it with a couple electric water heaters, and you will hook that up to the system. You'll shut your valves off on your water piping, so you essentially create a closed loop just within the chiller itself, and you'll hook this hot pack up and circulate hot water, create hot water to circulate it through the chiller and increase the refrigerant pressure above atmospheric to check for leaks. And that's not necessarily my favorite way to do it because it's very time consuming. You could actually spend all day, 6 hours plus trying to get this thing up to 2 to 3 PSI gauge in order to check for leaks. What I prefer to do is actually pull all of the refrigerants, and it's not the most economical, but in the long run, it's the best bang for your buck because it gives you time to go through the chiller thoroughly and make sure you find every single leak that you could find. You pull all the refrigerant, weigh it out so you know exactly what you're dealing with in comparison to the nameplate charge, and add nitrogen with trace 134A, or we used to use R22, but with the prices on it, our 134A is a lot more economical. And we'll increase the pressures up to 10 psi very, very slowly, very carefully. We'll get it up to 10 psi because there is a safety on the low side called a rupture disc, and usually those are set at about 15 psi gauge to where they will burst.
Got it. So, okay, so that's one big thing to consider is that you need to be really careful. You're not jacking this thing up to 200 psi like a typical high pressure system. So you want to be really careful and gentle with it, because even though they're supposed to burst at 15, they could potentially burst lower than that, I would assume, if you hit them all at once with pressure, correct?
Yeah, and usually before I add the nitrogen, I'll put in maybe 5 pounds of 134A, and I'll start slowly adding nitrogen. I'll make sure I'll have multiple gauges on the machine. I'll have one on the high side of the system, one on the low side of the system. One on the low side is sufficient enough, but I like to, doing something like that, I like to overdo it and make sure I'm safe all the way around. And I'll set my nitrogen regulator for like maybe 100 psi and just let it flow into the chiller. And it may take 2 or 3 bottles, depending on the size of the chiller, of nitrogen just to get it up to that 10 psi. Once it hits about 8 psi, I'll slow the flow down to about 50 psi outlet on my regulator and just kind of carefully watching my gauges. And once I hit that 10 psi mark, then I'll shut it down and go through it and start leak checking.
Okay, so I imagine when you're dealing with a unit of this size, first of all, there's going to be a lot of refrigerant to recover, so that's going to take a while. But then once you're getting something up to such low pressures, doesn't that make it kind of difficult to find the leaks? I mean, because I'm thinking like, setting something to 10 psi and finding leaks, it just seems like that would be kind of tricky.
It does. And I mean, well, let me ask you, when you're working on a split system, you guys have a certain method, right? When you're leak checking, there's a certain technique that you go about it, right?
Yeah. Well, first we do a little dance, and then we hold our nose. I mean, yeah, sure. I mean, there's a typical process.
I'd like to see a video of that because I want to compare notes to see if our dances are similar.
Right. Yeah, it's more of a dirge. Yeah, I mean, there's a typical process, but that's what I'm wondering is like, it just seems like you're dealing with such a large piece of equipment at such low pressures that it's got to be a real pain in the patookus, for lack of another word.
It's very tedious. It's very time consuming. To me, leak checking is almost an art form. It takes a lot of practice to do it right. To make sure you don't miss anything. You got to go real slow, and I will usually start at the highest point of the machine because collecting refrigerant will usually fall to the bottom, at the floor level. And so I'll start at the very top and kind of work my way down from there, checking every gasket that I could think of, every threaded connection. And then there's some hidden areas that people kind of forget, such as the motor terminal. Sometimes you'll have to take the cover off of the box that's connected to the motor and check inside there, make sure none of the motor terminals are leaking. There's other little electrical boxes mounted on for thermistors and different wiring connections and sensors. So you gotta make sure you hit every little nook and cranny. And then when you don't find anything, that gets really frustrating. Then you have to think of the possibility of, do I have A tubes that are leaking refrigerants into the water system? And so then you got to kind of go that route, which is a little more, it's not very scientific approach. Basically, we'll just drain some water into a bucket and stick our sniffer in there and see if we pick anything up.
Just stick it right in the water?
Yeah, fully submerge the whole thing right in the water and see what happens.
And you never pick up anything ever again because you've ruined your leak detector.
Yeah, that's kind of frustrating too, because sometimes you'll pick something up and it could be a chemical from the water treatment, so right. You got to kind of use your discretion, and before I go to the lengths of determining there's a leak in the tubes, I'll go over the chiller at least 3 or 4 times just to make sure I didn't miss anything.
And so how often have you found a chiller that is leaking in the tubes? A low pressure chiller?
Maybe only a handful of times. But those were cases where we kind of knew that something was wrong, that they could have possibly frozen up a tube or some other type of issues happened. Something got in the water piping and damaged the tubes internally. So it's actually pretty rare that you get a significant leak in the tubes themselves unless, there's some other outside force that could have happened.
What would be a cause of one of the tubes freezing?
Oh, that's a topic for a whole nother podcast.
Oh, okay. Sorry.
Well, improper recovery practices or charging practices, you can definitely freeze a tube on a chiller. So,
all right, I'll leave that there then.
Yeah, if you're not pulling the refrigerant out in the proper manner or not adding refrigerant, when you're breaking a vacuum, if you evacuated the chiller, then start adding refrigerant to it. If you don't do that properly, you could definitely freeze the tube. And,
right. If you started dumping liquid straight into a vacuum.
Yeah, you always have, whenever you got your repairs done, you evacuate it, you need to break the vacuum with vapor refrigerant until you bring the saturation temperature up above 32 degrees. I usually will go to like 35. And then you can use the push-pull method to get all the liquid into it. And you got to make sure you have water flowing. Technically, you don't have to have water flowing, but it's an added safety. If you do it right and water's not flowing, you shouldn't have any problems. But I always like to, messing around with stuff like that. I always like to play it safe and just get water flowing whenever I can. And always introduce your liquid into the lowest part of the system that you can, because you don't want to go into a valve on top of the evaporator or the condenser, just have liquid refrigerant pouring down and flashing off on hitting a tube or something like that. In a single spot, you're moving thousands of pounds of refrigerant, constant, hitting the same spot on the tube will definitely freeze it.
Right. And if it's a water system, then, I guess at that point you're at more risk than if you had a glycol system or something?
Yeah, well, especially on the condenser side, it's all water. On the condenser side, there's no glycol. But on the evaporator, you could have straight water, you could have glycol. But even with glycol, I try to do as safe as I can. That way I know, at the end of the day when I'm going home, there's nothing that I could have done to cause any problems in that aspect.
Right, and freezing a tube would be a pretty significant thing to cause. So you'd have to do the whole like Tommy Boy thing where you're like, "What'd you do?"
I think I would just get out of the car screaming that there's bees everywhere and just act like I'm crazy, and I would go for that reaction.
Okay, you went for the other Tommy Boy incident. Okay, good. Yeah. Makes sense. You learn everything I know about business. I learned from Tommy Boy.
Hey, he was pretty successful in the end, so it's not a bad way to go.
That's true. That's true. All right, so. And I guess one way that I'm probably thinking about this wrong is that if you have I guess I'm thinking in terms of in a high pressure system, when you have a leak, it's leaking under high pressure normally. Whereas when you have a leak in a low pressure system, it's leaking under low pressure. So it's not going to take as much pressure to even do leak detection, because if it's leaking under low pressure, you're going to be able to find it easier under low pressure. Does that make sense?
Yeah, I've actually had cases, even on a high pressure chiller, where we would hook up the vacuum pump to it and we would pull it down. We just couldn't pull down the microns on it. It would not pull down. And then we would put like 50 PSI, bump it up to 50 PSI, leak check it, and we could not find a single thing. And just by chance, it happened to be where we were purging the nitrogen and the trace gas out of the chiller, and we got down to like 5 PSI, and we ended up finding the leak at 5 PSI. And it was on the suction elbow. There was a butterfly valve on the bottom of the suction elbow. And what was happening was, with the higher pressure, it was actually causing a seal on the gasket with the higher pressure. But when we dropped it down to 5 psi with the lower pressure, the leak actually showed up and exposed itself under low pressure. It doesn't have enough pressure behind the gasket to seal itself.
Right. Yeah, and you'll see that in some cases, like some things that will leak under vacuum won't leak under pressure, and some things that leak under pressure won't leak under vacuum because of, they essentially get patches, a little patch of corrosion or something will cover it. And we see that in typical air conditioning. It's rare, but usually it'll still be leaking. It's just the rate changes. But we've seen some that's like, for a fact it was holding under pressure, and then you put a vacuum on it and then it starts having an issue, or vice versa. So again, it's rare, but you do see it on occasion.
Oh, yeah, absolutely. Yep.
All right. So any other top tips? It sounds like the main thing when you're working on chillers is stuff just takes a lot of time.
It is very time consuming. Make sure you have good equipment, good leak detector equipment.
That's what I want to ask you. What do you use? Yeah.
I had a Infocon D-Tech Select, but I actually just purchased a H10 Pro through your partner, TrueTech Tools.
TrueTech Tools. Did you use the offer code Get Schooled?
They had it on sale, and I used the offer code. And I did the easy financing. It was pretty awesome. It worked out.
That's like a trifecta. That's like a quadfecta of awesome right there.
Yeah, no, I was very pleased with it, and I've used it a few times already, and it's worked out very well for me.
Good. You just got to watch the battery.
Yeah, I was actually surprised. It only takes like 3 to 4 hours for it to charge up. To where my D-Tech, I'd have to almost plug it in overnight to get a full charge on it.
Yeah, I haven't used the latest version of the H10 Pro, so maybe it's because I would let them like fully discharge and then just sit for long periods of time. I don't know if that might have been some of it, but I have. The only issue that I've ever had with them is the battery life, how long the batteries last. So, cool.
Yeah. Last company I was at, I had the JB Prowler, and I liked that one because it used alkaline, it used AA's. So it was like, battery's low, just swap new batteries and you're ready to go. It was a nice little feature.
Yeah, I actually, in some ways, I almost wish that's how it was. But I guess with some of these, that would go pretty quickly. Have you ever used the PGMIR, the super high end Bacharach?
Is that English? I don't know what you're saying right now.
PGMIR, you don't know what that is?
I do not.
Really? That's the I don't know if you saw the video that I did. It's Bacharach's like highest end portable leak detector. Okay. It's like the technology they use in their stationary leak detection equipment, but it'll actually detect every refrigerant down to 1 part per million.
Okay. Yep. I just didn't know it by the name, but I did see that. That was pretty cool.
Yeah, it's pretty neat. So you need to get your employer to buy you one of those.
Well, I will. I'll mention it. We'll see
okay. Hey, tell them that I said so. I'm sure that'll carry a lot of weight.
Yeah,
Brian Orr says that I need a PGMIR.
And going back, the first time that we had spoken, you had asked me what is one of the things that I run into the most or I hate the most. And leaks, refrigerant leaks or air leaks on chillers has got to be my number one bugaboo that really drives me nuts because it's just such a time-consuming process. Find the leak, to fix the leak. Actually, we have a service local here in the Detroit area. They're a refrigerant recovery service. We'll actually utilize them to come out and pull all of the refrigerant out of the machine while I'll be off on another job doing something else, and they're doing that for us. So it actually saves us a lot of time. So once the refrigerant's out, we show up and we can start doing what we got to do to it. And when we're done, we just put the refrigerant back in ourselves, call them up, and pick up their tanks. And it's worked out very well for us. It's been a nice little setup.
Yeah, we've seen services like that. Walmart uses them sometimes. We're starting to do some more Wally World work, and it's
nice.
Interesting. And in those cases, on refrigeration, we'll just take one rack and pump it into another rack because you have these gigantic receivers that are designed to hold that much excess refrigerant. One thing I wanted to ask you is that because in a centrifugal system, the lubrication system is separate. I'm correct in saying that, right?
It has its own dedicated lubrication system, but it does mix with the refrigerants. It's kind of hard to describe, but in a sense, yeah, it does have its own lubrication system. The oil is not designed to flow with the refrigerant into the chiller itself. And, the oil pump pumps to the bearings and the seals and has a dedicated drain back to the oil sump. So
my question then is, in leak detection, typical systems, we're always looking for oil. Does that become like a non-factor then, where you don't see oil?
Oh, no. Actually, on the low-pressure chillers, depending on where the leak is at, if it's on the high side, yeah, you will see some oil in certain cases. But on high-pressure machines, no, oil is a huge red flag. We see oil somewhere, we're like, all right, where's this coming from? What's going on here? So, when I first approach a chiller, that's actually one of my first things I do before I break any tools out is I'm starting to look around for oil to see any signs of it. So on the York chillers, they use a open drive motor. So the motor is not inside the refrigeration circuit. It's an open drive motor that has greasable bearings, just like a pump motor or something like that. And it has a flexible coupling that connects to the shaft of the compressor. And the shaft on that compressor has a mechanical seal. And sometimes those seals will fail, but they will actually also drain a little bit of oil. As the chiller is running, there's a positive oil pressure pressing against that seal to help create the seal. And as a result of that, some oil will leak out of that, but there's a little collection bottle that sits under there, and there's an acceptable amount of oil that you're allowed to see within a certain amount of time. I think it's like 70 milliliters within 14 days. If it exceeds that leak rate, then there's either the seal is worn or there's a bad O-ring or gasket or something in there. So, yeah, no, oil is a definite telltale sign, but when you don't see the oil, it kind of bums me out because then I'm like, oh man, I actually got to try and find this leak and see what's going on.
Yeah.
There's nothing obvious. So
yeah, working is a real drag.
It bums me out. It really does.
I'd rather just sit in my van, listen to the rain, and be on podcasts all day.
Yeah, actually,
that is what I do.
I was actually I had to postpone this because it was storming pretty hard here, but luckily it let up, so it's worked out.
Good. Yeah, sounds good. So yeah, just to clarify, obviously on the low side of a low pressure chiller, you're not going to have oil because atmosphere is going into the system, nothing's coming out. So obviously you're not going to see oil in those cases, but I was just kind of referring to it in a larger sense.
Yeah, unless it's on the oil circuit itself, because there's external oil lines out of the oil sump from the pump that go to various areas on the compressor, and those are on a positive pressure on the oil pump. So if there's a leak in that area, you will definitely see oil, but that doesn't happen very often.
Got it. Cool. Makes sense. And yeah, so essentially you can either do using heat to drive the pressures up, or you have to pull the whole charge, pressurize, use another refrigerant in with the nitrogen and leak detect that way, and then evacuate it back down and recharge once you have it repaired, which either one of those sounds like a pretty massive undertaking, but that's the nature of low-pressure chiller leak detection, I guess.
Yeah, that'll take, we can spend all day looking for leaks and not find anything. And there's leaks because you can see your temperatures, your readings, your approach levels are rising. your purge timer is increasing, so there's a leak somewhere. Or on the high pressure machines, you could just tell when you're low on refrigerant because the thing is running dry, the compressor is just screaming, and that with all your other readings, you're like, yeah, this thing's low. We need to figure out where it's at. But the nice thing about that is you don't have to shut the machine down. You can start leak checking it right away. But yeah, on the low pressure machines, they're a little more time consuming.
Good deal. Well, I appreciate it. Sir. This has worked well, and hopefully I will get a chance to have that level of fun at some point and be able to do my own leak detection on a low pressure machine. And when it happens, you'll be the first to know. Yeah,
if you're ever up in the Detroit area, let me know. You can I can use the extra help.
I can bring my PGMIR that I got from TrueTechTools.com using the offer code GetSchooled.
Absolutely, I'm always looking for free labor.
Very good. All right, man. Thank you so much. Hey, thank you for listening to the podcast. Thank you for listening all the way to the end. Shows a level of dedication to just keep letting it play when you know that I'm not going to say another useful thing for the rest of this podcast. But I appreciate your commitment or your insanity or the fact that you're just zoned out and not even paying attention. Or maybe you fell asleep. Maybe you're just still playing and you're just snoozing away. And in that case, I might want to just sing you a little lullaby. I think I'll skip it. So thanks for listening, like I just mentioned. But one thing that I'm going to ask you, if you listen to this on YouTube or if you listen to it on Facebook or if you're listening to it on the website even, if you're listening to it on HVACrschool.com, thank you for that. But the best place to listen to the podcast is in the podcast app if you have an iPhone. And the podcast app is a purple little radio tower. That's what it looks like, at least. It's not actually a purple radio tower. It's just an app that looks like one on your iPhone. If you have an Android device, then you're going to have to go to the Google Play Store and you're going to have to download an app. And that app that I would suggest downloading is called the Stitcher app. And you can listen to the HVAC School podcast there. And all you got to do is just use search HVAC. You don't even have to type in the school. Just search for HVAC and you'll find the HVAC School podcast right there. And then subscribe to it. And then that way all you do is just go back to your app when you're ready to listen. And we'll be right there. Every new episode will come right there on your phone. And you can listen to it anytime you're ready. And that is the easiest and best way to listen to a podcast. You can plug it into your stereo in your car. Do they still call them stereos? I'm not sure. I guess they call them stereos. I don't know what they would call them now. MP3 player. I don't know what they call that stuff anyway. But in your car, there's a way you can listen to stuff. And so I would say you can plug in there. You can connect via Bluetooth if you're that fancy. Or you could use headphones for that matter if you'd rather. If you're in a noisy motor room like my friend Jeremy Smith often is, you can listen that way. But another thing I want to mention to you is that, finally, I already mentioned this once in the podcast, but I'm going to go ahead and mention again, and that's Testo's 60th anniversary, their fall combustion analyzer promotion. It really is a great promotion because if you double up, you can actually buy from True Tech Tools, use the offer code GetSchooled, get 8% off, then go to HVACrschool.com/fall promo, and you can then either get a 745 non-contact voltage sensor if you get the 310, or if you get the 320 or 330 series combustion analyzers, you can get yourself a brand spanking new Testo 770-3, which is the meter that I have in my bag, and it is a great meter. Some people have some issues with it out there in Radio Land, but not me. I like it. I think it's great. And so Testo is celebrating their 60th anniversary. And one thing I want to say about Testo is that Testo has been the most consistent sponsor that we've had. They're the ones who have backed us through thick and thin. And I really like Testo, and I really like what they're doing. And they've got some great new things coming up. Like I've mentioned in the previous episode, the one right before this, or when I say I mentioned it, it's actually Jim Bergman who mentioned it, that Testo is going to be working with the MeasureQuick app. And they're one of the first ones to sign on to do that. And that just tells you something about Testo, that they're confident in the product that they make enough that they're happy to share their data with an open source product like MeasureQuick, and I sure as heck like them for it because I think it's the right move, and I think Testo's doing a lot of the right things, and they're going to keep coming out with great products. There's some secret projects in the works that I can't tell you about, but I know you're going to like. So if you haven't tried Testo yet, you're going to find that it is a great product at a great price, and the fall promo is a great way for you to get a great combustion analyzer, and I'm going to keep just saying the word great until the end of this podcast. But that is HVACrschool.com/fall promo to find out more about the Testo 60th anniversary best in class fall combustion analyzer promotion. Now, one other thing, for those of you who are still listening, you're really forbearing with me because this was an especially long outro. But Jim Bergman mentioned that my super stupid dad joke the other day actually kept him listening all the way to the end because he was anticipating it. My joke about the chicken crossing the road. And so I've decided that from now on in every podcast, at least everyone that I remember to do this, any podcast that's worth its salt, I'm going to tell a stupid dad joke at the end, because I think there's something about technicians, something about being in this industry that makes you appreciate a good dad joke. And you can put this one in your pocket when you walk in the door. You can tell it to your wife or to your kids, or you can text it to one of your adult children if you like. But this one is something that I say whenever I go through the checkout line when I've gone to the grocery store and I have milk, which I often do. This is actually a true story. I often pick up milk on the way home. For those of you who don't know, I have 9 kids, and so we're always running out of milk, even though we have 2 refrigerators. And so if the cashier says to me, "Would you like it in a bag?" I just respond, "Nah, you can leave it in the carton." Thanks for listening to HVAC School. We'll see you next time.